number 7. So here is what it states. An analyst must decide between two different forecasting techniques for weekly sales of roller blades, a linear trained equation and a new approach must be used. A linear trend equation is formulated as Ft equals to 124 plus 2 times t, and it was developed based on the periods 1 to 10. So if I look at the data, looks like for the periods, it starts from 11, goes all the way to 20. Units sold, these are the quantities, actual ones, 147, 148, 151, 145, 155, 152, 155, 157, 160, and 165. So I copy pasted all this data into Excel sheet, and here will be using Excel. So yeah, this is the original problem. I copy pasted this piece as well. And one of the main criteria that we'll be using to decide which is a better method, either linear trained equation or naive approach. So again, the logic is whichever of these methods, either linear trend or naive method, gives you a smaller mean absolute deviation and mean square error should be selected. Yeah. So that is something that we have to calculate. And as per the slides, here are the formulas to calculate MAD, that is mean absolute deviation. And here is the formula to calculate the mean square error. So yeah, let's do first thing first. Since the equation is given, that is Ft, forecasted value equals to 124 plus 2 times time period t. So here, yeah, here like I have just added these two, yeah, colored columns, just separating. This whole deals with linear, and this whole is all about new method. So let's do the linear calculation first. So here is the equation given. So I will just start calculating for the time period 11th as per the linear method. What should be the estimate? Yeah. So again, please do not confuse between the actual values versus the estimate that we'll be making. So again, I will repeat this. The basic data that has been given is for time period 11 to 20. What are the actual sales units sold over here are given. And this is just a linear trend we are supposed to forecast using this equation. Yeah. So getting started. So here I'll start, yeah, equals to 124 plus 2 times time period t, that is 11 here. I'll, yeah, oops, sorry. This should be plus, doing it here. Everything looks correct to me. I'm saying enter. Awesome. And then what I'm doing is I'm dragging all the way. So I get all the linear equation for all the time periods 11 to 20. Yeah. So again, in other words, this is what that has been estimated. And on the other hand, this is what the actual value is. Yeah. So again, if you are looking for linear equation. So again, if I have to calculate MAD, the first thing I'll be calculating is the difference between actual minus forecast. So this is my actual, this is my forecast for linear. So I'll just do this over here. This calculation equals to actual 147 minus forecasted linear 146. Enter. And I will drag the whole formula all the way down. And these are the values I'm getting. And again, there are negatives. In the next step, what we are going to do is absolute. Yeah. So this is the mod. We are supposed to do an absolute. So that's what I'm doing. Equals to ABS. Selecting this value in cell D3. Enter. I drag this formula all the way down. Yeah, all the negatives will be converted to positives because you are only using the absolute value. Now the next step is for, yeah, this is done. Well, I'll just go ahead one step further. I already for the MAC calculation, I already calculated the actual minus forecast, which is same thing over here. One step further, I'll go ahead and do a square of that entity. So actual minus forecast square. So equals to actual minus forecast is over here. So this cell, that is D3 raised to 2. Enter. We'll drag this formula all the way down here. So yeah, these are the values I got for actual minus forecasted square. Now we are very close. So we have all the numbers that we need. So let's do the final math over here. So let's sum all these to calculate MAD. Let's sum all these absolute of actual minus forecast and divide them by total number of observations over here, which is, Yeah, so when I select these cells, the total count is 10. So here my n is 10. And similarly for MSc, I'll do the same for this square term, actual minus forecasted square. I will sum them all, that is sum them all and divide it by n minus 1. So again, same thing. My n over here, that is the total count is 10 minus 1. So I'll yeah, divided by 10 minus 1, which is 9. Yeah, so first thing, let's get this value. So equals to, I'm getting the MAD first for linear, equals to sum of, select all these, enter, and then final divided by n equals to this value sum divided by n is 10 in this case. So yeah, that's the value I got. So here indirectly what I got is MAD value for linear. Yeah, so I'll just go over here and say this is what I calculated MAD value for linear. So I'll just say equals to this. Yeah, that's my MAD for linear. Now next I will do the same thing, the MAC value for linear. Yeah, so I'm getting the sum of all these divided by n minus 1 equals to sum of all these cells equals to, then finally divided by n minus 1. So this will be equals to cell above, that is F13 divided by 10 minus 1. Yeah, I'll just do the math over here. 0 minus 1. Yeah, 10.11. So that's what I calculated for linear. My MSE equals to this value. Perfect. Yeah. So 2 out of the 4 values that we have calculated. Now the next step is do the same thing. Find the MAD for naive method and MSE for naive method, and then we'll do a comparison. And as per the logic, whichever of this method, naive and linear, gives us least value is something we should be going with. Yeah. So naive forecast. So you guys remember, like in naive forecast, all we do is whatever the previous value was for the previous time period value was, we just use it as for that for the same one. Yeah. So in this case, the actual unit sold for time period 11 is 147. So if I had to make a forecast for using naive method for yeah, time period 11, I should be using the same value for time period 10, which I don't know. So I'll skip that. I'll just put a dash over here. Next one, naive method forecast for time period 12. So that should be whatever the number that was there for time period 11. So in this case, it's 147. So for me, I will take this number and that will be my naive forecast for time period 12. Yeah. So equals to 147. That is the actual value for time period 11, and I press enter. So same logic applies. I will drag all the way down. Perfect. This is the forecasted. Yeah, these are the forecasted numbers using naive method. Next, exactly what I did over here, I'll be doing over here, except that for the first whole row, there will be no value. So dash, oops, sorry, it's taking negative. So dash enter, dash enter, dash enter. So now let's do the same thing, actual minus forecasted. Yeah. So in this case, my actual is for time period 12 is 148 and forecasted is 147. So I'll do exactly the same, equals to actual 148 cell B4 minus cell G4. So enter. I will pull this formula all the way down, drag it down. I get the differences. Next one is just to get this absolute, I'm doing the same. So equals to ABS of this value, that is H4, enter, drag all the way down. Perfect. I got absolute values for all these differences. Next one is just to get this actual minus forecasted difference square. So here you go, equals to actual minus forecast is over here. So this raised to 2. Perfect. So I have all these values. Now let's do a final sum of all these. So equals to sum of all the absolute values. Enter. So here I am. So in yeah, one more division and I should be able to get my MAD value for a new method. So yeah, actual minus forecast sum divided by n. In this case, just look over here. In this case, my n value, that is the total number of data points I will be using, is one less than what we had for the linear. So in this case, it's 9. Yeah, so that's the only difference to keep in mind. Equals to 36 divided by n value, which is 9. So that yeah, I'm getting 4. Next is similarly over here, sum of all these squared entities divided by n minus 1. So here also my n is 9, 1 less than the previous linear. So 9 minus 1 is 8. Yeah. So first is sum equals to sum of all these, so which is 202, and final division equals to this 202 divided by 9 minus 1. Oops. Yeah, oh yeah, that's correct. Then yeah, these are the values I get. So all I'm doing is yeah, summarizing it together. So MAD value using name method. So some actual. So here you go, that is 4. And this my MSC value using name method is this one, 25.25. Yeah. So let's format it a little bit. Let's use yeah, 2 digits. So yeah. So if I compare the mean absolute deviation between naive and linear, looks like my this one is lower. So let me highlight it as green. Same is the case. My MSC for linear is smaller compared to the naive method. So I'll highlight this as green. So yeah, this is the actual quantified information we have. Now let's go back and read the question. An analyst must decide between 2 different forecasting techniques for weekly sales of roller blades, yeah, and these two. So now since say you are helping the analyst, and based on that we found out that linear method is giving least of these two. So yeah, your final answer should be the ANALYST must select linear method because the MAD and MSE values are lower as compared to the new METHOD. Yeah. So yeah, this should be your answer here. So this is how you solve problem number 7. Next, let's go to problem number 8. Oops, I was trying a few things. So I'll delete these parts. I will delete this also, and let's solve it as a yeah, fresh 55. So let's go ahead and read the problem first. Problem number 8. It says a manager of seafood restaurant was asked to establish a pricing policy on lobster dinners. Experimenting with prices produced the following data. So if I read the table, yeah, the very first thing to do is read it, understand. So first column says average number sold per day, Y. So looks like there is quantity 200, 190, 188. So yeah, it's look like close to 200 is the range over here. And price is given over here in X. So yeah, $6, 6.5, 6.75, and so on. Looks like there is additional data over here. So same continuation. So average number sold per day, continued beyond 160. It's 155, 156, 148, 140, 133, and same respective price for them are 8.25, 8.5, 8.75, and so on. So looks like this is the least price, and this is the quantity sold at the least price. And as this manager has, he has increased the price. Yeah, so there looks like there is a systematic increase in price from here to 8, then 825 and 925. And this is the average number of sold per day based on these prices that have been increased. So this is the data collected. So the question they are asking is write a linear regression equation for this data collected and determine the correlation coefficient and interpret it. Yeah. So what I'll do is let me just copy both these, Control C, and let's go to our Excel data sheet. I'll paste the same thing out here. So yeah, so that we can refer it back and forth. So yeah, the first change I'm doing is I'm just putting it all together. So I'll say this is Control X and Control V. So this is my data. Well, this is extra. I'll just delete it out. So yeah, this is our summarized value. Perfect. I'll just make it presentable. So the very first question is write a linear equation. Yeah. So like I said in the class multiple times that moving forward, well, Excel is something that will be preferred. So yeah, straightforward. Let's go with our Excel equation. So yeah, the first thing I'm doing is I'm selecting all these data points from cell A2 until cell B13. So select all of these. And I will go to this tab over here that says insert. Then I will go in this insert line and select this. Yeah. So here Excel will do, it will take some default. So we have to do some basic correction out here. So for that reason, I will, yeah, just right click somewhere in the middle. So you see this, then I will select this tab saying select data. It will take me, to another tab like this. So yeah, first thing first. Yeah, I will go. So I will select this series one, go to edit and just check what series, oh yeah, series data it has pulled. So if I go here for the Y, yeah, looks like it has pulled the right one. So I'll say OK. And series two, yeah, since I know this is right, I will delete the series two from here. And I will go over here. It says horizontal category access label. So I'll say edit. I will select this up arrow and select all these prices. And yeah, do this. And one more thing I will add is, yeah, let's have it as standard practice of having a chart title. So in this case, my Y value is, average number sold, average number, yeah, sold per day, and X value is price. So I'll just use a symbol, say sales, or say sale quantity versus price. Yeah, so, and if anybody just looks at this chart, they will know what they are looking at. So sale quantity versus price. So this is my quantity and this is dollar. Perfect. And now, like I said, yeah, this is the first step done. Then I will select, this line over here and right click somewhere over here. And then I'll see another window pop up. I will select add a trend line. And another window will pop up like this. So make sure it, yeah, by default, usually that's an Excel thing. It will go with a linear. So I will, yeah, reselect it's linear. And they are also asking for equation as well as R square. So I'll just select this part as well as this part, and I will close this. Yeah. So yeah, another very important step completed. So now if I look at a question, it says write a linear regression equation. So when we selected, well, Excel by default did it for us. And that's a new industry norm, and that's what we are teaching our students in our all like other stats classes as well, using Excel or R program. So yeah, this is your linear regression equation. Yeah, so y equals to negative 5.7133 times x plus 202. So that's your first answer. And the second is determine the correlation coefficient and interpret it. Yeah. So again, here is my correlation coefficient r squared, and the value is 0.9762. So since this number is, and again, like as per the theory, r square ranges from 0 to 1, and close to 0 means there is very less or no correlation. So in that case, yeah, there is no correlation between the price versus the quantity sold. But in this case, it's the other way, right? I mean, the r square is very close to the number 1.00. So looks like there is a very strong correlation between the quantities that are sold with the price. So that's your interpretation. So maybe I will, yeah, well, for this, I'll just say, if I have to write an answer over here, I'll just add it over here so that it is documented. ANS will say linear equation is linear regression is, yeah, same thing, y equals to, well, yeah, move some things. A plus bx is the format, so I'll do the same. My a value is 202.3, B is negative, so I'll say minus 5.7133 times x. Yeah, so that's my equation. Control B, maybe I highlight if I want. I can. Sorry, Control C. I will say. Yeah, underline it as well. So that's my equation, and determine the correlation coefficient. Yeah, so I'll just write A and S. Yeah, same thing. I'll copy R square, R raised to 2. Yeah, I can use a different formatting, but yeah, let's stick with this. Equals to 0.9762, and interpretation is since R raised to R square value is close to 1.00, there is a strong correlation between the sale quantity and price. Yeah, so yeah, that's my complete answer over here. Just close the bracket. Same thing over here also. I'll close the bracket. So yeah, this is your problem 8 completed. Problem 9. Yeah, well, very similar looking data. Looks like there are a couple additional rows, but yeah, let's read the problem and we'll come back. Problem number 9. So here what it is. So it says Lovely Lawns Inc. intend to use sale of lawn fertilizer to predict lawnmower sales. The store manager estimates a probable 6-week lag between fertilizer sales and mower sales. The pertinent data he collected is, yeah, something like this. So looks like there is period fertilizer, number of lawnmowers, 6-week lag, period, oh, same. So looks like, yeah. So this is continuation, period 1 to 7, 8 to 14. Fertilizer sales, and with respect, like in terms of tons, is the unit. And yeah, this is the continuation. And number of mowers sold, 6-week lag. So from 1 to 7 here, and yeah, remaining 8 to 14 are here. So again, the question is write a linear regression equation for this data sets, as well as determine the correlation between the two variables. Does it appear to that a relationship exists between these variables? Will you do a good prediction or not? Yeah. So very similar to what we did. I'm copying Control C and pasting it in our Excel sheet so that we can refer here. Yeah, perfect. And I will just do this data cleaning part. So yeah, since it's a repetition, I'll say Control X and Control V. And since this is extra duplicate doubled, I'll just delete that. Let's make it presentable. Here you go. Oops, yeah, one more time. And yeah, I will just make it this way. So yeah, this is period 1 to 14. Fertilizer sale in ton, yeah, 1.62, yeah, all the way down. And then number of more sold, 6-week lag. So like, yeah, very similar to what we did in the previous problem. We'll be using Excel. So this is my X value as per given. This is my value, Y value. So yeah, I'll just select these from cell B3 to cell C16. And I'll go to this tab over here, insert, and select this line. And again, like Excel will have its own preferences. So we'll do the more correction as well. But like we said, let's correct the chart title. Fertilizer sale versus, well, the Y must be first. So number of movers sold. So movers sold versus fertilizer sale. Yeah. And again, like for your problems, or even if there are problems like these are there in exam, I won't be very picky on your title. Yeah, some realistic, some sensible title must be good enough. So here, this is what I use. So more sold, that is my Y, comes first, versus fertilizer sale, that is my X. So now I'll go here and try to do some corrections. So like I did before, take my mouse cursor somewhere in the middle, do a right click, say select data, and I'll select the series one and do the edit. And yeah, well, this should be my Y. So yeah, it's flipped. No worries. Yeah, I will select all these. I should be doing this back. I select all these and this way. Say OK. And I will delete this, and this should be my horizontal X. Yeah, here you go. Select all these and say, yeah, perfect. Now it looks right. And here, see, this trend looks very different than we saw in the previous problem. And yeah, we got this line. Now I'm right clicking over here, saying add a trend line. Say linear, display equation on chart, display R square value. Should yeah, it should bring, and then yeah, closing this. So to the best, Excel code, it tried to fit in a line, and I mean this is like statistically very correct, significant. This is how, even if we have to solve this problem, this is how we will be solving, and this is exact the linear equation we will be getting. So yeah, let's make this a bit bigger so that we can read it. So I'll use 16, yeah, readable. So this is the equation I got, a linear equation. So that's the first question, write a linear regression equation. So yeah, this is the equation, y equals to negative 0.1165 times x plus 10.231. So I'll just write it over here. So linear regression, or linear equation is equation is same thing. Copy. I could copy paste as well. Equals to 0.231 negative 0.1165 times x. Yeah, so that's my equation. And the next one is determine the correlation between the two variables. So we determined, yeah, R square is a good predictor. Does it appear that the relationship exists between these variables? Will you yield a good prediction? So again, as per the theory, yeah, R square should range, like it ranges from 0 to 1. So it looks like, yeah, it is within that range. Close to 0 means very less correlation, so very less relationship, and close to 1 is very strong relationship. So looking at this number, it looks like it is not close to 1, rather it is very close to 0. So yeah, that's the answer. I will write it down over here. So A and S, the R square value is close to 0. Therefore, yeah, there is, or you can say it can be inferred. Therefore, it can be inferred that there is no significant relation between, well, you can write more sold versus fertilizer, or yeah, in simple words you can say between x and y. Yeah, so that's your answer for problem number 9. So yeah, this is how you'll be solving these problem 7, 8, 9. Thank you so much. Have a good day.